Hello there, and welcome back to another tutorial of paraview, mastering paraview, and we're working with streamlines. Okay, we still work with a little bit two more videos with streamlines, then some more advanced concepts. So something that seems relatively easy now. We have covered so many concepts, but there are many things to do that you can do with streamlines. So what we're going to see now, besides now revisiting some previous concepts, is how to animate these streamlines. Very important. So far we have worked with static data, steady data with the streamlines. So we can also do use on steady data. So there is another technique. So what we're going to use here, the stream filter plugin that we're going to see, but there is another specific filter to do on steady. The concept is pretty much the same. Okay, so let's work with this, and well, I guess now for on a steady case I will need to rerun this case and put some on a steady data. Probably we'll find something much easier. Okay, but pretty much the idea it is the same. So basically my workflow we have visited. So we're using inside data. I have found that this is the best data. Most of the solvers, commercial and open source, will save in inside. Otherwise, you can use the VTK, which is also equally fast. But for some reason, I prefer to use this data. I don't recommend you to use native data for those using OpenFOAM, SU2, or Fluent Store System, because it tends to be very slow. We show that in some other videos, but it is up to you. So we're using inside data. The inside data, I don't recall from what solver we were using, or probably those with a good eye you will know that this is immediately OpenFOAM data. It is cell center. So the first things that I like to do when I use cell center data is to transfer that data, convert cells data to point data. Why? Because there are some filters that require point data. So just an extra tip here, you have filters, and let me search for a specific filter. Now we're doing streamlines, so look at that, you have a string tracer, but this one here is highlighted. You can use it, but as you look at down here, you see that a string tracer with custom sort, the one that we're going to use, it is gray out. Why? Because it requires, you see here, vector field with a point attribute. The same with this one, and the same for a strict line. A strict line is the one that we use for on steady data. So you see here that you have strict lines through time. Okay, we're using string tracer, static data, but we can animate it, and that is what we're going to see, how to animate that data. So basically, let me go escape, interpolate the data. I want to pass also cell data. So remember that you have these advanced options here. So sometimes if you don't see some options that I see here, it's because of it. Also, I want to remind you I'm using OpenFOAM 6, paraview 6, okay, the latest version. So some filters might not be available in older version, but I think what we're doing, everything is available in older versions. So now let me extract blocks here. So I want to use my internal mesh where I'm going to release the streamlines. Also, I want to use inlet 1 from the surface. From this surface, I want to release that, and let me take the pipe here. Okay, so this is the extract block filters that also you can find here in alphabetical. Somewhere there you have it. Where do you have it? Where? Okay, there you go. So let me do some renaming to make things easier. Right click, internal mesh. This will be inlet 1, rename inlet 1, and this is, let's call it up. Let's say walls, and that's it. So I want to see this one here, and let me add some transparency there, 0.3, and there you go. So this is my scene, quite nice. You get the point that now I want to release the streamlines inside the pipe from this surface. Easy peasy lemon squeezy. So let's do it. So you go here and you have a string tracer, and this is not the one that we want to use. Remember, this string tracer, you have point, you can release from lines, or you can release from a point cloud. okay, I want to use a custom source. Okay, so let me go here, string tracer with custom source. Okay, see that now it's available because we have the point data. My input, this one, seed source, will be this, and here you have a whole bunch of options. You don't see all these options, remember, here you have this. Okay, so basically I need to use the velocity, the vector field, and all these options. I'm not going through all these options. Also, I think we visit that, but you can see here that you cannot control the number of points from where you are releasing those string lines. So in theory, you are releasing those string lines from every single point, mesh point that you have there. Okay, so you see that is a lot of stuff that you are going to release, and let's see what happens there. So be careful that this can be time consuming, these operations, in the sense that you need a good GPU. Okay, so see that pretty much this is what we have, and let's see what, let me put here this patch. And as you can see, you are releasing but from a lot of points. Okay, not only the nodes, is releasing for a lot of points there. Okay, so the question is, how can we control that? Okay, remember that also you can change it here. Let me go here, increase this time. So you have the tooltip here, you hover on with your mouse and you get there the options. So usually to have the complete string lines there, just increase this in maximum string line length and should be okay. So see that even though I have a good GPU, see that it's taking some time to do this operation, so be careful. So it is important to control that. To show off a little bit, so let me put here the color, let me change the color range, and let me put here 0 to 5. So see that is super nice. But to remind you also a little bit advanced, you go to the button here, you have ray tracing, again good GPU. So if you enable this, see that now automatically you have these tubes. Okay, super cool. Okay, super nice. Okay, and actually here we can see that, yeah, you're releasing is better. You can see that everything is being released now from all these, from the nodes. Okay, so if you have here a super fine surface, it will be now a lot of string lines. To make it even cooler, you have here shadows, and now you cast shadows. So fantastic, you can move your source light and so on. And to make it even cooler, I always like to change my background, and let me go here, background gradient, and this is a nice background, and there you go. Okay, so there is a lot of stuff you can do. Okay, again, you need a good GPU from this, but okay, later I guess I have a video I can prepare a video to show all these options, but yeah, there you go. Let me use a single color. So the idea is now, let's reduce the number of strings like releasing. Remember, our goal is to animate this stuff, but we're revisiting now some consequences and showing you some other options. So basically, we can somehow mask this this inlet surface now to reduce the number of points. So we did that already, but if you forgot it or if you haven't seen that video, let's redo it. So select this surface, you go here, and there is a filter called mask points. You have it here, and basically here you do that, apply a mask to those points. Okay, so let me go here, and well, you can go here and use point Gaussian and see the points there, and you can go here, and I think here you can control, no, you don't control that there, where I forgot where you can control the point Gaussian, and actually you need to go down somewhere here. You should have, okay, here there you can control that here, 0.01, no, too small. Let me put it here, 0.2. Okay, so these are the points that you have there, yeah, that we're releasing from this point. So you have on ratio there, so you are skipping every 2. So see that you have a lot of points from where you are releasing. So if you want to release that, you can put here 5, and see that now is something, okay, that you can handle better. Okay, you can also limit the number of points that you have here, the maximum number of points and so on. So you have many options, okay, so play around there, but I like to use this. So actually this is a nice field here to release the streamline, but I like to use this random here, so you have different options as well here. Let me put everything also, I don't want. So usually I like to use here surface samples, so in base of the surface we'll do a nice sampling there. You can do it bound based also in the bounds, also on, and play with those options. The random parameter, the seed number for randomness, I don't recall how to set it, somewhere should be, but it's not important. But anyway, so let me generate vertices and 4 single vertex per cell, and this is it. So now look at that, we reduce the number of streamlines just to, let's say, 50. Let me put 50, and this is quite nice, quite cool here. And now let's release from those points. Okay, so this is what we're going to do now. Let me go point Gaussian here, and let me make it a little bit smaller. Change this one, and there you go. So now that you have there, you get the point. So you can apply the same technique here in the pie. We already did this in some previous videos. So let's go filter, string tracer with custom source, and here you want, here set source, this, apply. Okay, nothing happened because remember here, select your vector velocity, and there you go. Enforce from those streamlines, and to make things super cool, apply it there, and you have it. Your nice photorealistic visualization. Now let me increase this one to 10 to cover the whole domain. Let me change velocity there, and this is it. Okay, so easy peasy so far. Okay, no problem. And let me disable this stuff. So what we would like to do now is to imagine that you have these spheres released there, if they are going to follow this streamlines and do some nice animation. So many other commercial tools, they do have that already integrated. Let's see how we can do that in paraview. It's relatively easy. So important concept here is that, look at that, you have integration time. Okay, so this is the variable that we're going to use. So basically we're going to apply a filter, a contour in integration time, and then we animate that integration time. So see that you have everything going here from 0 to 36 seconds. Probably there are some particles that remain trapped in the boundary layer, like probably this one there and so on. So that's why they're so slow. So if you want to limit this, also you have some other filters like threshold and so on. So I'm not going to do it, but you get the point. Apply some other filter and limit everything to values from 0 to 10 and so on. So let me go here, change this to 15, and yeah, you have there everything. So okay, first select the streamlines. Okay, why do I have 2 string tracers? I didn't erase one. Okay, let me erase that. I don't recall that one, so I erased that one. It's something I left behind. What I wanted to do here, it is one. Okay, apply a contour of what? Integration time. So it's up to you, whatever you want to do, but it's integration time that we want to do. So remember that we're using here, you have there this method run execute and so on, whatever. And here you select your variable, and then here you put a value. It doesn't matter the value you put here. Okay, so to show you, so see that this is time 0. Now you get time 0, 1. See that the points now move, and actually this I think I can control it here. Yeah, and let me put here, and if I change this to 0.9, you have this. Okay, and this is what we're doing, animate this. Okay, that's all. You need to put a list of value. You can put any value, doesn't matter. When we animate, we're going to animate this value from minimum to maximum. Okay, so it doesn't matter what you put there. So that's it. We're at this point done, and well, we can do things much nicer because I can apply there a glyph, a vector, and you can put a vector, an arrow there, so you have it there. Let me use velocity and no scaling, and let me put a little bit larger there. There you go. So probably much larger. and I want to use velocity. So this is what we have, okay? So this is okay, so we can go, okay, so velocity, and now how we can animate this. So you have the straight lines and it will move, and to show you, so if I change now this contour, and let me put it here like 5 seconds now they are going to be there, and see that the vectors are pointing in the direction they are coming. So super cool. So how do I animate that? You need now to access something, another new toolbar, okay, which is time manager. So I guess this requires another video. This can be very, very confusing. I still get confused, very complicated. I think the developers can make it easier. But what we want to do is that first thing that I recommend you deselect this stuff, okay? So you need that one. So see here that you have this time 200 corresponds to the simulation time or iteration, 200 iteration. So you need that one. Let's say that I want to animate, double click there from 0 to 1. You can force that one, number of frames. So you're going to do an animation of a static field. Let's use 50 frames. So say 50 frames from 0 to 1, okay? You have it there, and now this is what you want to animate. So see that you can access a whole bunch of stuff, filters and things that you put there. But I am interested in the contour, and you get the point that in contour we have the integration time of those isosurfaces, so we can animate that. So basically you are taking that isosurfaces and you saw the effect of this isosurface. So look at that, you move it there. So this is what we want to animate. Click here, you have it there, and now this variable can be animated. So if you double click here, you see that time 0 to 1 is going to use this interpolation. You have different options there, so play with that. I'm not going to talk, it's self-explanatory. And the value of time will be from 0 to 36, the maximum integration time that you have. Remember, you can clip this one, apply in any filter, but I will leave it like that, or you can do it as an exercise. And this is it. Play, and there you go. Your nice animation. Okay, your fields and you have it there. So you are animating an static field. So as easy as that. So yeah, nothing else to add there. Okay, and what I can add is that probably you're doing this and you might say like, okay, maybe you have your vectors or here, and I will at this point I would like to add more particles there. How do I do that? So it's a little bit tricky, or not tricky. You need to repeat and repeat. So you do these 2 steps, you repeat it here. Let me create another contour. So this stuff can be also parameterized using Python, so it's not a big deal. Integration time, it doesn't matter what you put there, but let me put 0.1 just to see you have it there, and then you can apply another glyph here, and this one, let me put an sphere. I have it there. This sphere is no orientation, no scaling, and let's put 0.4, a little bit smaller. 0.05 there, and this is cool. Okay, then important also remember to select all points here, or we put all points because we know that we don't have that many points there, otherwise can be dangerous. And this is it. So now we have a second glyph. So see that we're a second contour or glyph. We have contour 1, but here we can access also contour 2. We put it there. And what we can do here, if you click play, you're going to see those superimposed. Now, so let me click play, see that you have it there superimposed. Even it's quite nice. Now you have that there. But I want to add a delay in the second one. Okay, let me go. So that you can do it here, and you say second one time start at minus. Let me put -3 or no. Probably it's too much, 0.3, or I don't recall which scale will use. Okay, yep. point, and you see there that now they are out of phase, and run this one 0 to 1, 0 to 1. Okay, yeah. Let me go here, contour. Okay, let me put this one 0 and 0. Okay, press play, and there you go. So now I have the second one. Let me see, because okay, let me put it here. And already probably it's too much the value put here, or minus 0.05. Let me put here, apply. Okay. 2. Okay. And okay. Yeah, there, and you press play, and there you go. So this is adding this small delay, playing there. So as you see, it can be a little bit confusing. Probably 0.05. Let me apply. Let me see. Okay, so yeah, it was there. So I add that delay, and if you want to add another one, you get the point that reproduce that. So that can be done on automatic. There's Python. So Python script. Let me go 0.1 there. Apply. And then when it reaches the time, you have it there. Okay, so you have the second one, and then you can inject another one, and so on. So this is it. Okay, and you can put, obviously you can put your streamlines there, and you have your nice animation. Okay, and you can go photorealistic and so on. So this is it. Okay, animating and a static field. So the last part, I don't want to send this one. You might say, okay, how do I save this animation? So I always like to add my annotate time filter to put the time. Okay, so this is the time that will create it from 0 to 1. Okay, so we create it here in the time manager. So you have this one, and it's very easy. Just go there, and let me give it a name there. Save your movie. So choose a format. Let me put up, let me select, I don't recall. Let me select this one. Very important, frame rate. Let me put 50 frames per second, and this is it. Okay, and it's going to save the animation. And then, well, I forgot. Yeah, I chose format. Let me say, I forgot what format I chose. Yeah, MP4. So let's wait for this one. That can be sometimes can be time consuming. Okay, so finally we're done. Let's see what we have here. Let's see. Okay, I didn't see. Okay, so, and there you go. So you have animation, the other particles enter, and there you go. And you see that you have your annotate and filter in the top. So quite cool, quite nice animation. Okay, so there you go. So how to work with streamlines. So as you see, might think that it's easy, but can become, you can overcomplicate things and add new filters and new objective. So yeah, we visit a lot of advanced options, and at this point we are done with this case. Streamlines, this is the basic stuff. Next video I'm going to show you something. Is a plugin that comes with paraview that not many people know it, so I want to show you that, always related to Streamlines, but it's just to show nice color. So hope you like this video. Okay, thumbs up if you like it. If you didn't like it, you have there your comment section, and you can write anything there. So I don't erase comments, so put there if you like it, don't like it, of what we can improve. So thank you for your attention, and see you next video. Bye.